Welcome back, everyone. In part 2, we're going to focus on training the model and then evaluating the model. Let's get started. Okay, here we are at the notebook where we left off last time. As always, we'll begin by importing time in order to get an idea of how long this training time takes. As always, this is going to be hardware dependent, so your training time is most likely not going to be similar to mine, depending on what kind of computer you're running. And then we import our start time at the very end, and we'll go ahead and say total time is equal to start time, and then we'll take the current time, time.time, minus the start time. And since total time is in seconds, at the very end of all this, we'll go ahead and print out total time, and this is going to take quite a while to train because we're dealing with very large images and we have quite a few parameters in our model. So we'll go ahead and measure this out in minutes. We'll say total time divided by 60 seconds, which will give us this in minutes. All right, now it's just time to fill in everything else in the middle. And this is going to look very similar to what we've done before. So first we need to decide how many epochs we'll go ahead and train for. We'll train for 3 epochs here. After 3 epochs, we should be breaching around 70% accuracy, which is pretty good considering the fact that just random guessing would be 50% accuracy. So our model would be learning it by that point. And then let's go ahead and make a couple of variables here. We'll make a variable called max train batch. And we'll basically set limits as far as the maximum size of the batches. So we're going to limit the number of training batches to 800 and the number of test batches to 300. So basically that means we're going to train the model on 8,000 of the available 18,743 available images and test it on 3,000 of the 6,251 images in the test set. It's up to you if you want to wait longer. So this basically limits on number of batches. And that's because that'll help you essentially not have to train through an entire batch, and it'll make the epochs go faster. You do not need to set these maximums, and you can always play around with these maximums if you're willing to wait longer. But we'll go ahead and set these a little lower, so we'll go ahead and say 800 and 300. Remember, each batch here, this is going to be, each batch has 100 images, so that means the total, each batch has 10 images. Let me delete that. And that means the total is going to be 8,000 images. There, so that's the max. And then similarly, we're going to have 3,000 be the max number of images in our test batch. And you can always change those numbers up. And in fact, technically you can remove these numbers if you want a single epoch to actually go through the entire training set. That will take much longer though, so we'll go ahead and save ourselves a little bit of time by not going through everything. And it's mainly for the purposes of filming. Let's go ahead and keep track of our training losses and our test losses as we go train through this network. So we'll train correct, just the same trackers we've done previously, and we'll say test correct. So we're keeping track of our training loss, our test loss, and then the number correct during training and testing. And now we'll say for I in range epochs, we'll go ahead and keep track of how many we got correct during training and how many we got correct during the test set. And for every batch, comma, and remember we get xtrain, comma, whitetrain, essentially the label, whether it's a cat or a dog, and enumerate the training loader object that we created earlier. What we'll go ahead and do is we can limit the number of batches. Again, this is technically optional, so optional limit number of batches. And what's nice about limiting this at first is if you just want to test out your network and make sure everything works, you can always just set the number of batches lower, then not spend as much time training. And then when you're ready to essentially train on everything, you just comment out this line. So say if the actual batch number is equal to the max train batch number, we'll go ahead and break out of this. Okay, so again, this is optional, and it's just to save us a little bit of time at the cost of not training on every single image. And then what we'll say is we'll just simply run the model. So how do we actually get a predicted image? We simply, into our model, CNN model, we will go ahead and pass in xtrain. And let me make sure I use the exact same notation I did earlier. So it looks like I used a lowercase m, so I'll go ahead and make sure this is lowercase here. So there's our CNN model, pass in xtrain. That produces its prediction, whether it's a dog or a cat. And then the loss is criterion, ypred, yTrain. And then we want to tally the number of correct predictions. And I'm just going to copy and paste this code since it's exactly what we've seen before. And I'll also copy and paste the update parameters code since that is also exactly what we've seen before. We've already seen this a few times with Safar and with MNIST. All we're doing here is we tally the number of correct predictions by counting up where the matches are between the predicted values and the correct yTrain values, and then we update the parameters. Okay, and if we want to print stuff out, maybe every 200 batches we print a little report. So I'll say if batch mod 200 is equal to 0, go ahead and print out maybe the following information. Let's go ahead and print out what epoch we're on. So print out the epoch, and then let's also print out the loss we're on. So we'll say loss and print out loss item since we need to grab it outside of that tensor. And then finally, let's go ahead and print out, actually, we'll just print out the loss. And if you want, you can also print out what batch you're in. There's a lot of information you can print out, but that should be enough for us, just the epoch and the current loss. And hopefully the loss goes down as we train more and more. And then right in line with this for loop, we'll say train losses, and we'll append that current loss so we can plot it out later. And then we'll also append the number of instances we got correct. So we'll say trn correct. Okay, now it's time for our test set. So we'll also run this during training, but since we want to make sure we don't update our weights and biases with the test set, as always we say with torch, no underscore gradient, and then we'll say for b comma x test comma y test in enumerate the test loader, and we'll essentially be running the exact same style of code. We'll go ahead and limit this batch. Again, I want to really make it clear this is optional, just to save yourself some time during training. And then we'll say, if that happens to be the case, go ahead and break out of this for loop. And then we'll grab the predicted value. So we just pass in our XTest features, so the actual image, pass it into the CNN model, and then we'll go ahead and see if we predicted it correctly. So we say predicted, and in fact this code is exactly the same as what we did before, so we can just simply copy and paste it. So we're going to copy this guy and this guy. There we go. So we have the predicted torch, and then we're comparing this not to yTrain, but in this time it's yTest. And this is going to be batch correct, but the way this is working out, this is essentially the same as just test correct. So what we're going to do here is we'll say at the very end of this, test correct is equal to test correct plus batch correct. Okay, and then we'll calculate our loss in line with the with statement. So with criterion, yval, comma, ytest. So at the end of the epoch, we'll calculate the loss. We'll also keep track of the number of losses for this test. So we'll say loss on that particular test. And then test correct, we'll go ahead and append tst underscore correct. All right, so it looks like we have everything. Let's go ahead and zoom out, make sure our indentation's correct. But overall idea, really nothing we haven't seen before except for setting limits on the number of batches. And again, just to make this completely clear, this is optional. You don't have to set the number of batches to a limit. You can go ahead and just go through the entire training set for an epoch. Your training will just take longer. All right, now before we actually run this cell, we got to make sure to fix a couple things here. Want to make sure total time actually goes towards the end. So I'm going to cut this, and then after everything's done training, right at the end, I'll put total time here. And then we made a little typo. We have epoch as being printed out as epoch here, when really what we need to print out is I, since that's the thing we're iterating through. That way I can say epoch 1, or really epoch 0, 1, and 2. All right, so that should be everything correct. Let's go ahead and run this and make sure everything's running correctly. I will run this right now, and it may take maybe a few minutes before you see that first initial loss report come back. But let's go ahead and fast forward in time until this is done training. Okay, so we just trained for those 3 epochs here. Let's go ahead and save the model. It's always a good idea to save the model right after training. So what we're going to do is say torch.save. We'll call CNN model up, ask for its state dictionary, and then we will save this, and you can call this whatever you want. So let's call this my 3 epoch model.pt. Go ahead and run that and save it, and then let's evaluate the model performance. We can do a variety of plots here. I'm just going to copy and paste from the lecture notebook, since these are different plot commands that we've seen many times already in the course. The first one, I'll go ahead and plot out the training losses versus the test losses at the end of each epoch. So we go ahead and run this, and we can see here that the validation loss was decreasing, and then the training loss was also decreasing but starting to level out. What would be interesting is to see this continue on for maybe 1 or 2 more epochs and see if we continue to get performance improvement. Let's go ahead and do the accuracy, since that's going to be more interpretable. I will copy again and paste this from our lecture notes here, and the reason again I'm using 80 and 30 is because of the size of our test batches. Recall here that we had 800 and 300 as a maximum training batch size, and remember each batch has 10 images, so that's how we get this value of 80 and 30, since we're saying for T and train correct and test correct. So we go ahead and run this, and we can see here validation accuracy at the very beginning is horrible, which makes sense. This is test data that the model has never seen before, but even immediately just after 2 epochs, it shoots up. And training accuracy is also beginning to go up. So it would be interesting to see this behavior extended for a couple more epochs and see where we begin to level out. But it looks like right off the bat, we're performing better than just a random guess. Recall, since we only have 2 classes, a random guess would be around 50%, which is why it makes sense that the validation accuracy at the very beginning was around 50%, since it's essentially just a random guess. And it looks like after training for 3 epochs, we exceed random guessing, and we're going around maybe 70 to 75% accuracy, which is better than just a random guess. And in fact, if we want to see how many we got correct, we can say out of the test correct, grab the last item there, and say multiply by 100 in order to get the percentage. Well, I'll go ahead and first divide it by 3,000. Remember, that was the size of our total correct, and it looks like we're getting 80%. So if we want this as a percentage, we can say 100 times the test correct, and it looks like we're getting 80% accuracy. Okay, so we showed you now how to actually run this model using your own image data. What we're going to do up next is we're going to focus on how to load pre-trained models. We can see here that even at just 3 epochs, it's taking a long time to train this. So let's save some time by using a pre-trained model and see how our performance improves as well. I'll see you there in the next lecture.